I tell you what, we will kick off. We will let people in as they start to come in. Good morning. Thank you for joining us. I can see you from various parts around APAC. You're in for a real great treat. You've got the best studio we've ever seen in our masterclass series. It looks amazing. I really like it. I'm very jealous of the background and the studio that Bennett has. But we're super lucky this morning to have Bennett Fitch, president of Noria Corporation, who is going to be talking to you for the next 90 minutes, 75 to 90 minutes. And his session is Practical Tribology for the Next Generation, Enhancing Equipment, Reliability in Industrial Operations. So for the next 90 minutes, if you are you're here, please mute yourself. If you have any questions, put them in the chat or raise your hand, and enjoy, folks. Over to you, Bennett.
Well, thank you so much, Ian. Hope everyone can hear me all right. So give me a thumbs up if you can. I see heads nodding, so we're good. As Ian said, I'm calling in from our studio in Tulsa, Oklahoma. So it's just past 4 p.m. Central Time in the United States. Still Thursday for me. So lucky you guys, it's Friday. You get to enjoy the weekend a little bit sooner than me. So I'm looking forward to myself, but it's also going to be a little bit cold. And so thank you guys for calling in. I know most of you are in, Australia or nearby regions. He said 75 to 90 minutes. I'll be surprised if I get that far, but let's see how your questions end up at the end. And to be honest, I don't mind if, unless one of you has got a lot of questions and wants to continue to ask questions, you can interrupt me partway through and we'll discuss something and I'll get back on course as needed. Not a problem. For those of you who are not familiar with Noria, Noria, we're in Tulsa, of course, is our headquarters, but we're a worldwide organization specializing and leading the industries with lubrication and oil analysis, training, and consulting. So we train more people, public courses, private courses in those subjects, machinery lubrication being most common, than maybe everybody else combined. And that's us over the last 25, 27 years. Actually, we just today earlier in our offices, celebrated our company anniversary. We have some weird traditions here. I won't bore you with it right now. So we're excited about that, 27 years. And our partners extend all around the world, including in Australia. Eventful Group is one of our partners that helps with, putting on our public courses there and other events similar to that. And we very much appreciate them. I appreciate welcoming me, inviting me to be part of this mainstream masterclass series. It's an honor. Hopefully, I can share a few things that are exciting and interesting to you all. I teach courses all the time, so I'm going to jump to my bread and butter here in a little bit related to lubrication, but from the context of practical tribology. So I'm going to switch back and forth on my presentation here. Let me see if here it is. Practical tribology for the next generation. I'm probably in the middle generation. I've been around in the industry in the world of tribology for over 20 years myself. And so I have a good idea on both sides on the academic perspective of tribology and the practical side of tribology. Well, before I get any further, I'll say, if you don't even know what the word tribology, that's okay, because not a lot of people use it. Only in certain places they will. But if you know anything about lubrication, friction, and wear, that's the definition of tribology. If I were to rename a lot of our courses, it might just be called tribology, but nobody will go because nobody knows what that name is unless they go through a course. But lubrication is an important field that a lot of people may not recognize early on because it's not intuitive. The important components of lubrication does not come naturally, even to those who live in a mechanical world. I went through a degree program for mechanical engineering over 15 years ago, and even then they were limited when they brought up topics related to lubrication. Very minimal. Yet, if you think about it, lubrication is a critical component to anything that moves, whether it's sliding, rolling, moving, you name it. A gearbox, a bearing, even things behind here. It will not last 1 minute, without it starting to heat up, and then it leads to friction. The friction leads to wear. Who knows how long? But lubrication in there will solve all that if done correctly. Now, the reason I wanted to have this title of Practical Tribology for the Next Generation is to pair up with some topics that one of my colleagues here at Noria presented on earlier this year at the Reliable Plant Conference related to the next generation and what things they're looking for and skill sets. I'm actually going to introduce it a little bit about that here with some of his slides. But before I get any further, I'll just kind of cover a few learning objectives I'm hoping to walk through. One is just simply understanding the role of contamination control. Contaminants, what do they, how do they impact machines? Next, I'll talk about what this inspection 2.0 technique is about. Then I'll jump into integrating modern tools, everyday tools, things that we can use that are in our own pocket that can be impactful and bring in the next generation into these industries. And fourth is seeing how this plays a role in the overall reliability space, how applied tribology has a role. But what is important for that next generation? You know, that's the question. The next generation being those entering the workforce or maybe been in the workforce for 10, even 15 years, but are still transitioning to figure out what it is they want to do. You know, how is it they want to apply themselves? Even those who have been through degree programs or even trade programs, do they actually have the skills necessary to complete their job? Are they happy with their jobs? So a study done by Wes earlier this year, actually he was referencing a study done by the National Association of Manufacturers in the United States. They identified that there's over 2.4 million that's going to be forecasted a gap of skilled workers by 2028. You know, what that means is that we, have a lot of people that are going to be trained over that period of time, and we need to make sure we have that availability. We're going to have a need, and it's hard because that type of workforce isn't readily available today. Right now, it is an average of 44 days between finding, looking, searching for that particular hire and actually hiring them. So that's the average, 44 days. And then you have to decide whether or not that's going to fit correctly. But what is that next generation looking for? They're looking for in their possible career things that can help control their schedule. They don't want the wild cards of what's going to impact the uncertainties. Of course, they want safety. Safety has always been a critical component. We don't even recognize it until there is an event. I think the new generation definitely favors more technology. Lots of different things can be described as technology. Tools in the industry are technology, but more importantly, it's the digital technology that they want to leverage. And we can use that to our advantage. More with digital tools and less with the hand tools, even though the hand tools are necessary, they're kind of paired together. And they're also looking for things that are jobs that can help strengthen their stance on a better environment. Does their organization they work for are they going to be positive towards the environment? And also they're looking for, of course, good money, and they're looking for a retirement opportunity down the road. What's the long game here? They're looking for all those kinds of things. So of that, the three things that really stood out, what is important to that next generation is one, work-life balance. Work-life balance, 60%, don't even have, this is a study done, 60% don't even have boundaries of what's considered work time or other parts of their life. The second one here is skills development. Being able to have the opportunity to learn new skills through their job, continuously improving, continuously learning. Will their job provide that? And the third one is recognizing they're having a positive impact. So this was a keynote session that was presented, like I said, and to recognize the important need of our industry to see the needs that are different with the next generation, different than what was in the past. 50% related to work-life balance, 50% of job seekers rank this the most important. That means when they're looking for their next job, whether it's pay or who the manager is or the type of work it is, 50% of them, the most important thing was work-life balance. Making sure they had enough time to be with their families and they can, have a control of those components there. The next one here was the skills development. Like I said, 63% consider this essential to career success, building their skills, so having something that they can leverage moving forward. And that includes certification. Manufacturing workers who earn an industry credential, let's say like a lubrication credential, earn $2,000, it's US dollars, more annually, and are more likely to be employed than those who did not earn a credential. So think about that, and add that to every possible credential after that. That's a big deal for people to have that opportunity. Reliability is a big part of this. That's why I want to tie this keynote in. Reliability is a big part of this because technical advancements, technology can help with that, them adopting these tools. Specific certifications that relate to that future growth. I was just listening to a podcast early this morning on the drive to work, and it was about a coding company. And they said, the things that get developed better and faster and meaner in terms of a better program are things that are interesting to them, and things that have the tools that are, the result is something that's exciting, not necessarily the thing that's needed most in this world. You have to tie those two things together when they develop a skill. Is it having a positive impact? So that's the third thing here is the positive impact. 70% consider a company's social impact as important. So again, reliability impacts this. Reducing of waste. Waste is a big component of this. And it's a lot, especially if you look at the CO2 emissions of what we're doing in industry. If they feel like the role they're in is going to reduce that, then they are going to feel happier about their job. So what does that have to do with tribology? Why am I going on this tangent about the next generation in the workforce? Well, tribology does have a way of answering this, and I'll go back to what Noria does and why do we even exist. And Noria was founded on the premise that every plant, every facility, every mine site has a hidden plant that must be found. A hidden plant. I'll explain that in a second. Well, actually, I'll go ahead and explain it now. It relates to being able to uncover what things are being done every day or money being spent every day that is really not amounting to any impact on the facility, any positive change on revenue. And when the company makes more money, everybody else makes more money, producing more, faster, whatever it might be. And if we can discover what those waste components are and reduce them and then increase the overall averages, then we essentially are producing a multiplier of what the facility currently is or was. Could be ×2, could be ×3. And we have case studies. I've seen this over and over where this has played out to just uncover what is considered a hidden plant. Also, maintenance is the #1 controllable expenditure in the plant. I'll talk about that a little bit. And lubrication or lack of lubrication or the things that impact lubrication, and this is the world of tribology again, applied tribology, that is the #1 cause of machine wear. Contamination and lack of proper lubrication is the #1 cause of wear. I'm not just saying that. You can talk to any of the manufacturers of the bearings, the pump manufacturers, the motor manufacturers, the gearboxes. They'll say the #1 reason why their components fail is due to some sort of mechanical wear, and the majority of that is going to be contamination or lack of lubrication. So what are we going to do about that? Well, all progress, all change depends on the change, and we must the changes that we're making, and we must enable that change, whatever the catalyst may be, or whoever that is. And that's what we at Noria are. That's why I want to talk about this, because I've witnessed countless times individuals becoming educated, building skills, and them becoming the catalyst to change in their own organization. That's the obvious cause and effect. So knowledge is power. Knowledge is the #1 enabler for change and the #1 influencer of human behavior. How do we change someone, especially if they've been doing something a certain way? You know how those habits are. We're creatures of habit. So we're going to continue to do something until we are, feel justified it should be done differently. So that's a conviction that must be taught, to explain to someone why they should. It's not what to do, but why. That's really the importance of training, is why something should be done. And then on top of that, the what. And once you have success, is the last thing here is about conspicuous success. And you see that down here. I think this gets underplayed, misunderstood. Maybe that's a better way of saying it. Misunderstood. Conspicuous success means presenting your findings. When you have success with something, even small changes, this is important for the next generation, seeing the small changes, making sure everyone's aware of it. Because if it's not showcased, then there's not going to be the additional investment or time and resource investment to make that grow even further. And I'll kind of explain some scenarios about that coming up here. But that's the long game and how to keep things sustainable. Showcasing that conspicuous success is the number one way to sustain a program. So take a step back. Let's talk about tribology for a second. We'll have a little bit of a Tribology 101 course. And then we'll get into contaminants, contamination control. So tribology is the study of lubrication, friction, wear, and that the lubricant is reducing that friction. But let's not forget, friction is also considered a good thing at times. The way our tires break on the road and keeps us from sliding all over the place. That's friction that we like. But at the same time, as you're driving, you're experiencing drag. All the air around you slowing you down. That's something you're trying to reduce. So friction's both a good and a bad thing depending on the context, and we just need to recognize it as part of the equation. But understanding that friction exists and lubricants can help, what else impacts that? Well, it's impacted by the motion, the type of speeds, whether it's sliding or rolling motion, the temperature. As temperature goes up, the viscosity goes down, the oil thins up, and that's a big deal. The load on the equipment, the overall environment, operating environment, the shock loads, and the type of lubricant and the way the lubricant's being applied. When I say lubricant, I'm talking about either the oil, of course, or grease. Grease is the oil, though, with a thickener, and it presents itself on the components to separate out components. But it doesn't do it by default. It needs relative motion. It needs not too much load on the component. It's a balance of those three factors. So when there is lubrication in practice, the most effective form of good lubrication is what we call hydrodynamic, or there's also elasto-hydrodynamic lubrication. And when that occurs, you have full separation of components. These surfaces are moving relative to each other as a careful balance between the viscosity and the load and the speed. But under certain scenarios where the speed is too low, or the load is too high, then you're going to have a collapse of those two surfaces. The viscosity can't really do enough there. So in exchange, you're working with the additives, the wear and friction control additives. If you've ever heard of anything like anti-wear additives or extreme pressure additives, these are those type of additives that protect and provide what we call film strength. Film strength is how the lubricant protects surfaces by means other than that viscosity. So that's also known as boundary lubrication, where these additives, anti-wear additives, play a role. And they don't prevent friction altogether, but they help reduce the effects of it. Now, all the while, you see that these surfaces aren't showing themselves to be perfectly smooth. That's totally normal. Under these conditions, the gap between these surfaces is at a size that we can't even recognize with our own unaided eye. We're looking at 1 micron or 2 microns or half a micron and rolling element variance. We can't see things individually without a microscope or something. That's less than about 40 microns. We can't even, our hair, for example, is about 80 microns. So it gives you an idea. We're talking about something almost 1/100th of the thickness of our hair. And that's the film thickness that is protecting our machines. It's the difference between having perfect lubrication and a machine that's smoking and burning and frying and leading to failure immediately, as a lubricant at that depth. Along with that, we also have the fight against contaminants. Contaminants that can get in there. The solid, maybe dust and dirt that's even in this room right now we can't even see because of that same reason. It's too small, but it's still bigger than that film thickness. So it gets into that oil, and this is happening blind to us. Yet it's causing this sandpaper wear wearing down of the machine surfaces, and it leads to wear. So we have to recognize that and provide good lubrication to overcome it. So things like good lubrication, things like contaminants, and then need to control that. Those are the top reasons why machines fail. I'll jump ahead a few slides here and show that. The Pareto principle, if you ever heard of it, it's called the 80, also known as the 80-20 rule. It's used in a lot of different ways. But one of the most impactful ways it's looked at in our industry is that 20% of the causes of failure are responsible for 80% of the occurrences of failure. But if all the reasons why machines fail, 20 of those, and that's actually shown here in blue, 20% of those are responsible for 80% of the occurrences. And across all those averages, it adds up to being particle contamination, moisture contamination, wrong lubricant, degraded lubricant, and then eventually misalignment, imbalance, and the list goes on. There's eventually things that continue to add up to other reasons why machines fail. But contamination's there as number one, and then lubricants right there behind it. So I say that because that is necessary to observe that as a root cause to failure. Now, with most of you, or many of you, I'm not sure what all your roles are in your organization, but I have to imagine you have a familiarity with condition monitoring and all the technologies and several technologies out there to monitor the conditions of our machines to predict when machines will fail. That's predictive maintenance. And predictive maintenance, like vibration analysis, there's others like thermography, acoustics, motion amplification. They're all very critical at telling us that the machine is experiencing a failure mode. But that is also the problem. It's telling you when there's a failure, not necessarily telling you that it's all that it will lead to a failure. And so that's what leads me to talk about, if you haven't seen it already, something called the PF interval curve. This PF interval curve represents the time domain between the time in which the failure is first detected and the functional failure. The functional failure is when the machine is not able to really do its job anymore. And so this chart right here is this time down here, and then we have machine performance. Over here, this is 100% machine performance. And that's early on, machines early in service. But something causes it to begin to wear, and we may discover it right here, right here, right here. And at that time, if we pick it up with vibration, okay, great. We're catching it ahead of some kind of catastrophic event. We're catching it ahead of an unscheduled failure that would lead to undesirable breakdown and downtime. But that said, even if you were to fix it here, this is permanent wear occurring on the machine. The bearings or the gears, there's metal coming off the surfaces that you can't just put right back unless you refinish the surfaces, which requires a full rebuild. So the best case scenario there is to stop the reason why it's wearing down and work with the machine in that state. So that machine in that state right here, the best case scenario is to go straight across from here where there's a drop in performance. That drop in performance could be 10%, 20%, but that's a performance that's going to impact production, energy that's being spent. These are all tied to lubrication issues as well, because the electric motor has to work harder. There's heat being generated to produce it, to push through that extra friction. Lubrication is the core of all that. But ahead of all that, lubrication can also be the answer, because proactive maintenance in this proactive domain, which is different than the predictive domain, predictive maintenance looks at the failure in progress, but the proactive domain looks at the root cause and attempts to fix the root cause before the wear ever begins. So proactive maintenance is root cause oriented, meaning we're looking for particle contamination. We're looking for changes in the fluid properties that if we leave it that way, it'll eventually lead to wear. If I were to take that pump, which let's say is perfectly lubricated, and I take a glass of water and I pour it in that pump, it's not failing immediately, but it will lead to failure eventually in the near future. But if I were to inspect on a side glass, let's say that there's water in there, I can fix that before that ever happens. So that said, this is all different types of wear and friction that can take place. But what are the economics behind all this? Where can the next generation capitalize on, using tribology to their advantage? Well, a typical maintenance budget, there's a lot of different things that go into it. But the biggest part of it is the maintenance, labor, and repair parts. That labor and repair parts are a big cost, but the majority of the impact of that failure is the downtime. On average, there's at least 5 times the cost, the downtime cost as it is the cost of repair. And so you have this maintenance budget that's significant, but 5 times that, at least the majority of it, is the downtime. Well, why are these machines failing? Why does it lead to the need to have repair parts and maintenance available to make that happen? It could be miscellaneous, it could be mechanical fatigue, it could be incorrect component assembly, it could be incorrect choice or monitoring and usage of the lubricants and contaminants. If you were to analyze which of those causes of failure are addressable, these right here, 70% of those causes of failure are addressable. 70% are the ones that are on the proactive side or the root cause oriented side, are something that we can do something about. So once again, applied tribology is about recognizing the impact that lubricants have to reduce or minimize friction and use friction to your advantage eventually, all to reduce wear as well. It's a concept that doesn't come intuitive, but it's fundamental to the industry as a whole. But it's simple stuff that can be applied. That's why the next generation can take this and answer a lot of needs here and make their careers a success as a result. So root cause oriented, well, the name itself kind of helps explain what this is about. You think about the root of a problem or the root of a plant, a living plant. If you were to pull the plant from the roots, then you will essentially help eliminate the problem or eliminate the weed, let's say if it was a weed, from growing back. Versus cutting it from the stem right here, who knows, maybe you get lucky and it doesn't come back, but more than likely the problem will repeat. You'll have what they call the 4R treatment, where you have to repair it, replace it, rebuild it, remove it. Things will have to be done over and over. And there are symptoms over here. These are all symptoms of a failure. One of these you see right here, like it's running hot. Okay. If it's running hot, let's say this electric motor, well, you don't see it, it's on the edge of this. Electric motor over here that is experiencing, I can probably move the camera a little bit. Go over here. So this electric motor, if it's running hot, okay, that's going to start, reducing the lubricant film. We're going to have an impact on the energy consumption. And if this electric motor will fail sooner, even the lubricant will break down faster based on the Arrhenius rate rule and other chemical rate rules that suggest that chemical reactions are happening twice as fast for every 10 degrees Celsius increase. But why is it running hot? If it's running hot and I have a fan, I can do have a fan down here and I put the fan on it like that, okay, it's cooling down, but I'm simply addressing the symptom, not the root cause. Now, I'm not saying that putting a fan on it to cool it down is not part of the solution. You might need to, because that helps make sure that you can buy yourself some time. Give me this fan. You might need to buy yourself some time there before you find the solution. But the real answer could be a lubricant issue, could be a contaminant issue, could be contaminants in the lubricant, or it could be on the outside, getting in between those fins and causing it to not have good heat exchange outwards as the heat gets generated. But that said, if we only address the symptom and try to put a fan on it, the problem will repeat. But if we focus on the root of the reason, the particles, whether it's the wrong lubricant or external heat from some other source, if we focus on that, then the problem will be eliminated. And that's what we need to focus on. So conditions of the root cause, and that's related to contaminants. That relates to maybe misalignment and imbalance, external high temperatures, incorrect things about the lubricant. Those are all root cause conditions. We call that proactive maintenance. Not we, but everybody calls that proactive maintenance. That focuses on the root cause. There's technologies that help with that. Of course, but oil analysis is a big condition monitoring technology that focuses on that. But just even doing sight glass inspections can tell us if something is going wrong there. The benefits sought are a fault-free machine life extension, and the number of failures overall will be reduced. Recognize how this is different, though, from predictive maintenance. Predictive maintenance looks for the failure symptoms. Great. We want to know when a machine is failing. Wear debris analysis helps with that. That's great. Vibration analysis is great. Helps us recognize when a failure is happening. And we can have early detection. That's that benefit is sought. That sought is an early detection of that fault. And when we detect it early enough, the impact of that failure is less. Just like we saw in that PF interval curve, the sooner we see that failure in progress, the less of an impact it's going to have overall. So it's all about early detection. But this early detection and impact of failure is very different than proactive maintenance, is trying to reduce the number of failures as a whole. It never fails to begin with. So contamination is a core part as to why these machines fail. Like I said, if you even look at the bearing manufacturers, what do they say? Well, here's some data from SKF. Here's some data from NSK. SKF, you went as far to suggest or say, with lubrication and contamination as the top reasons, bearings, their bearings, the largest bearing manufacturer, I believe they still are, their bearings can have an infinite life. They can last forever. When particles larger than the film thickness are removed. Think about that. I'm not sure if anyone's going to speak up and tell me their thoughts on it, if they're brave enough and share with me what you think. But that's a pretty bold statement. Their bearings can last forever if all particles larger than the film thickness are removed. Anybody have a thought on that? If not, it's okay. So think about it. Film thickness, I mentioned earlier. It's often, for rolling element bearings, that's less than a micron. So the idea of removing all particles less than that film thickness, it's not impossible, but it's definitely impractical and not even cost justified, because there's a lot of effort into that. But that said, there's still an important message that you're trying to say there, that the less contaminants you have in their machine, the longer their bearings will last, period. So where is that break even? When can we address that? So contamination control is the applied tribology that's really easy to execute on. It's just a matter of awareness, explaining the why behind it. So that's why I have a strong belief, and I've seen it, it's not just a belief, that there's evidence. It's not circumstantial or anything, but it has to be recognized, or that the next generation can focus on things related to lubrication, contamination. I'll even talk about inspections here in a minute as a way to solve these needs and have an opportunity. So when I say contaminants, what am I talking about? Here's typical. If you've ever seen ISO contamination codes, this is a way in which we measure contaminants in an oil sample. That number, 20, 18, 16, it's above what we want. It's too much contaminant. 23, 22, 20, that's too dirty. A good number here is like 14, 13. But how much does it take to make an oil dirty? If I was to take a drum of oil and it was perfectly clean, so 55 gallons or approximately 208 liters of oil, drum of oil, assume it's perfectly clean, and I was to take an aspirin tablet and then smash it up into small little particles, the equivalent of that volume of particles, and I was to put it into that drum of oil, that is 1 part per million, or equivalent to an 18, 15, 12 ISO code. That's already too dirty for most turbine systems, most hydraulic systems. These are components, machines that are sensitive to contaminants. But the reality is I could take that aspirin tablet, smash, and throw it in the air, and it will turn into a fog and disappear. and no one will ever see it because it's the particles, individual particles are so small. In reverse, those particles are already in the air and they're floating around every day. And that can accumulate anytime we leave lubricant drums open or machines that are breathing without a good breathing system. All of this is impactful. So as lubricants are cycled through a pump in a hydraulic system, even if there is a filter, if the filter isn't removing more than the particles that are coming in, then you're always going to have a system that gets dirtier and dirtier and dirtier. And so recognizing that, the fact that contaminants will continue to invisibly destroy our machines can be a huge factor. So proactive maintenance can be kind of distilled into 3 steps here. First, setting targets. We can use those ISO codes. ORS stands for the optimum reference state. You can look that up online, what that's about, but that's really about just focusing on what's optimal rather than what's maximized. So every machine, based on its conditions, has a different target. How clean does it need to be? Then you have to take specific action to reduce the ingression and improve filtration. And number 3 is measure the contamination level. So what gets measured gets done. That might require a particle count or just sending it off to a laboratory to measure the particles. But before you do any of that, you can't just say, I want to clean up my oils. You have to have a target. And so you have to know how clean are your oils? How dirty is your oil? Are you taking good samples to know how representative are those oil samples? So if your current cleanliness levels, I know you might not know what these numbers mean, but if they were at a 2118, that's not very good. That's a very contaminant, high contamination oil sample result. But if I was to take that down to, let's say, a 1613, this chart represents the machine life extension. So I connect those 2 areas right there from current cleanliness to new cleanliness level with better filtration. The blue represents a hydraulic system or a diesel engine to experiencing 4 times the life out of that machine due to particle removal and keeping particles out of the oil. Well, how do you remove all those particles out of the oil? Well, yeah, you can have a filter. I have lots of filters over there, and have the oil go through a filter. But are you going to put that on every machine? Well, some machines might need it. It's critical. Other machines, you have to balance that out with other solutions because it's going to be cheaper to keep the contaminants from getting in than it is to remove it out with a filter. The cost of excluding a gram of dirt of oil is probably only about 10% of what it'll cost you once it gets into the oil from before. So we have good breather, good seals, minimizing wear generation, making sure the new oil is clean. That's a 10th of the cost compared to what it is once it gets into the machine. And then once it's in the machine, for critical machines, it might require having good filters as well. There's a balance. It's kind of like the caloric balance. If you ever, look at your calories, you burn calories, you consume calories, or however it might be. I might be going to the gym, but if I consume more calories than I'm burning, then I'm not going to get the results I'm expecting. So it's a balance. Same thing with contaminants. If I'm consuming more contaminants in my machine because I'm not thinking about the small seals, or lack of seals, or not good breather. Most machines do need to expand and contract their pressure, so there will be a need to pull in air from the air around it. If I'm consuming more contaminants than I'm removing, then it's not going to be in balance. So contamination control is the application of practical tribology. And most machines, unfortunately, do not have the modifications from the OEM directly when you buy them. You just buy the gearbox or the pump or the motor. And it doesn't have these accessories that may be necessary to fight against contaminants. They're needed. You need to make modifications to improve the cleanliness. Dryness relates to keeping moisture out of the machine, helping to reduce the temperature. I think that's a little more intuitive to most of you. And de-aerate is about keeping the oil that may be circulated from entrainment, the air inside the oil. That can cause a lot of damage to the machine, including cavitation wear on pumps and journal bearings. These components can wear from the most, unless you know about it already, the most unexpected causes, even air bubbles in the oil. There's a lot of things we have to protect against, and that's all about proactive maintenance. So we can catch these faults by first we can keep them from getting in there, but once they do get in there, we can monitor the possibility of it inside the machine through oil analysis, through visual inspections, through sensors and other technologies. And this is where the next generation can recognize the opportunity with applied tribology. Catching faults proactively. Interesting, because when we say catching fault, the fault is a machine that's already experiencing a failure mode. Whereas proactive maintenance is supposed to uncover that before the failure ever even begins. And if something's going wrong with the oil or something's in the oil, it doesn't mean the machine's failing. So it's hard for a machine to fail without the oil knowing about it first. That's the message here. We can see what's happening to the machine by seeing what's in the oil itself, just like when you do blood analysis. You take a blood sample, you might go to the doctor, and you take they take a sample, and you feel fine, everything's fine. But yet the results come back, hey, there's some things going on here and here and here. I would know. I'm not feeling those effects, but there's an indicator of something in my body or a change in my body that will lead to those effects. Same thing can happen with machines. But same thing with inspection, just making observations. All right, so you see this image. This is inside a hatch of a reservoir. There's a lot of reportable conditions here, things that are wrong inside this sump. Would you be able to report them? All of the 10 reportable conditions. Would your laboratory, your oil analysis laboratory, predict and find, well, not predict, but find those conditions? Or your vibration program? When you see this, you might see a few things that pop out to you, but I'm only asking you to find it, whether or not is that the case every day when a machine like this is in service and someone walks by. Maybe some of you are familiar with, I got 2 young kids. I got an 8 and a 5-year-old. My 5-year-old daughter loves highlight magazines. I don't know if you know what those are. They come in the mail, and they have a whole bunch of kid stories. And they have some of these pictures like this. These pictures are a find and seek. You're trying to find the little objects. There's lots of objects in this picture. Do you see them? And if you're looking at this, do you find hidden objects? I'm not talking about the obvious raccoons, but things that are more hidden. You don't have to answer, but look at it. Think about how many. Do you see 1? Do you see 2? Do you see 5? Like, for example, there's a compass right there. And there's a few more. Okay, I ask this because I haven't told you what those objects are, but I'm telling you that there may be something to look for. Imagine that new generation, a new technician comes into the plant, not really given enough apprentice-like training or official training on how to inspect machines. And they're told that I visit plants after plants after plants. I'm in different plants almost every other week for the last 15 years. And different facilities all around the world, even in Australia. And what I see is that when someone is told to inspect a machine, they're rarely told what to look for. They're rarely told what is considered normal, what is considered abnormal, and showing them examples of that. They're just told to inspect the machine. And then when they go to the machine, of course, okay, the machine's there. It didn't blow up. The looks okay. They're not really knowing what to look for. Just like if there's a difference between what the average person might see at a crime scene versus an investigator, a forensic scientist. They know to look for specific details. There is a gap in skill between the average layman and the person who's trained as the investigator, as the forensic scientists to look for key details that mean this, that mean this, that mean this. But one of the easiest things to do is to show someone what is considered normal and abnormal. And that could be integrated into everyday tools that we see and use as we walk up to the machines. So going back to this image here, if I was to then say, okay, here are the objects to look for. There's a kite, there's a flashlight, there's a cowboy boot somewhere, there's a whale. And you're like, what? How's there a whale? A balloon, a slice of pie, a bird. There's the bird there. Remember where that one's at. Ice cream cone, and so on. There's several objects here that you can't see unless you start to recognize what to look for, right? Now, what if I took this further and said, okay, here is an example of the picture or the object. I just gave you a list. What if I took it further and said, this is what the pan looks like, this is what the balloon looks like, and the whale looks like? You'll be able to recognize. This is very basic, simple stuff that maintenance teams that can do for a new generation that don't have to really have 10, 20 years in a job. I can teach someone in 3 hours how to inspect their machines and what to look for. And then they can make huge impacts in uncovering issues and show the why behind it. So going back to even this right here, can you see those 10 reportable conditions? There are 10. There's a lot of things. Why is the level of low? Like there's a difference here in the impact the water had at a higher oil levels, resulting in varnish. And there's all kinds of. There's no gap here. There's no gasket. I mean, there's rust down here. There's aeration. There's several more. If you want the whole list of the 10 conditions, you can email me later on, and I will be happy to show you the whole list. This comes from this whole exercise I'm telling you comes from a yet to be published book that's called Inspection 2.0. It's a huge book. It's going to be almost 1,000 pages of detailed images on what to look for in different conditions of different machines and the why behind it. What does it mean? How does it impact reliability? But everyday things, the opportunity of a well-trained human-based inspection. Consider just the observations of this gearbox. What is it there that the person can find on a level gauge, on the bottom down here or the top? What is there to look for? What if the inspector is told isn't told or trained what to look for? What would she report? What would he or she miss? There's a lot of gaps there. The experience and the mindset of a detective needs to be emphasized as intentionally looking for the clues associated to the cause and the effect of failure. That's what they need to look for. So let me go to this. This is a breakdown of how, once you have good sight glasses or having a device here called the bottom sediment and water bowl, it's a very well established, proven inspection device that you can add to a gearbox or a pump or a reservoir to look at things that are heavier than the oil, such as debris that falls down or water. That's why it's called a bottom sediment and water bowl. But these don't come on the machine by default. You have to add that to the machine afterwards. You have to modify it. Yet there's this idea that when you buy a new gearbox or a pump, what the OEM has done to outfit it, you don't touch it. That's what they think. You want to keep things the way the OEM said it should be. Part of it might be the warranty, but their part of it is a lack of understanding that it's not necessarily modified the right way. But there's a lot of things from an inspection. So we're getting into that inspection topic here, Inspection 2.0, the daily inspection, the things to look for. And one of the most, it could be a lot of different things you're looking for. We call it the daily 1-minute inspection, because once you're trained properly on what to look for, and this is just a few of them, 13 of them, they can happen real fast. So you can, just like a crime scene investigator can find things within the majority of the data they're going to find is going to happen within the first 30 seconds because their eyes are tuned to what to look for. After that, it's just a matter of validating and showcasing it. There's a lot of data here. But best practice is to reduce is to reduce the subjective elements of an inspection. One of the biggest issues with a visual or a sensory based inspection, what do I see, feel, hear, is that it's subjective. What Stephanie or Guy or Martins or everybody thinks about an inspection on a particular machine might be different, especially from what I think, so we're going to see things different. That's subjectivity. And that doesn't play well when we're trying to make objective decisions. Converse to how vibration and acoustics and thermography, they give us objective data that we can utilize and watch the trends. So the opportunity is to take what we do every day with our own senses and turn it into a more of an objective observation, utilizing tools to collect through our senses and provide explanation on what to look for, what's considered, as examples, what's considered normal and abnormal, and let those results trigger automatic follow-up actions, just like it is in oil analysis with the trigger follow-up actions if certain things happen. You need to have the right tools that tell you what to look for and how to report it. There's a lot of different types of things you can look for, even on a typical gearbox. There's over 120 different inspectable conditions on an average gearbox, and only about 10% of those are intuitive. That's something that my 8-year-old son could determine on his own. The other 90%, it takes skill. It takes being trained to look for certain things. Even on the cyclass, there's lots of different conditions. So the skill of the inspector can only also, the second thing here is not just the enablement of the inspector himself to be trained and skilled, but also to let the machine be inspectable and put things on there that can help with that inspection. Unfortunately, cyclasses are all not made equal. There's all kinds of colors, shapes, and sizes, and sometimes they look really good where you can see the oil very clearly. You can determine what's in there that shouldn't be in there. Other times it's just a black mess or a confusion, and that's unfortunately way too often. We have to look for these conditions. Does your technician know how to inspect and how to respond to even the conditions you see here? This is a bottom sediment and water bowl. They know what to look for. There's even a magnet right here, by the way. This picture right here indicates a sludge that has ferrous debris in it that is indicating a wear-related event. This inspection can happen every single day by anybody walking by. But yet for decades now, a typical magnetic plug on a drain port has been the go-to solution or option for a drain port, but you can't even inspect that until you actually pull the drain plug out. With this, you can see it every single day. So, and new machines are not sold with the right things. They're sold bare to the bones. That's how they're trying to get the market share, by reducing their costs, unfortunately. So there's a lot of different things, whether it's a breather to reduce contaminants, ingression, better filtration, better ways to add oil with, let's say, a quick connect that can help enhance the application of the lubricant without letting the air around it contaminate the process. The fundamental piece of all this is recognizing the plant around the equipment is filthy. There's dirt everywhere that will damage our machines, but we're blind to it. And we are not just creatures of habits, but we're also we rely too much on what's intuitive to us. I'm guilty of that too as well. So if something doesn't make sense to me, I don't see it in front of my face, then I'm probably not going to act upon it very quickly. So you have to make things easier to understand or educate people where it may not be clearly understood without the principle being understood. So applying tribology.
Bennett, we have a question from Martins. I don't know if you can see it there.
Oh, I'm sorry. Let me see where I can pull it up.
No worries. If you want, I can read it out.
Yes, please do.
Okay, it says, in what ways can we quantify the financial impact of doing oil analysis to monitor lubricant condition in order to improve equipment reliability? There's a couple of other questions, but that's the first one. I don't know if you can
Yeah,
see them. Then that's the first one.
yeah.
There's probably three or four
I
there.
just pulled it. I just pulled it up as well. In what ways can we quantify the financial impact of doing oil analysis to monitor lubricant conditions in order to improve equipment reliability and to get management? So you remember, there's more there, but I'm hoping I can help answer this question already here. Earlier, I said, what gets measured gets done. So that was a third component of the proactive maintenance. So Ian, by the way, thank you for pointing out there's a question there. And so measuring it is simply just tracking the particles, right? And currently, there's a few things here, but currently there's going to be a cost associated with doing oil analysis. So let's stay in the topic of oil analysis for a second. A well-implemented oil analysis program is probably going to cost you anywhere between 2 and 5% of the equipment value itself. Now you have to go through a process to make sure you do it right. Otherwise, the bad practices of oil analysis, like taking bad samples, and that just ends up being a wasted activity because you're not getting the results you expect. And more often than not, that facilities don't check all the boxes to improve the integrity of their oil analysis program. But the benefits sought from a well-implemented oil analysis program is going to be anywhere between 15 and 20% of the equipment value by seeing the reduction in downtime, seeing the reduction in repair costs. So if you actually have a maintenance, everyone has a maintenance budget, and many of you may have as well a calculation that identifies the amount of downtime there is. You can go through a calculation. I've done this hundreds of times. It's part of our what we call our ascend assessments, the first stage of looking at the current state of a maintenance program and their lubrication activities. You can look at the overall maintenance budget and determine what piece of that is actually addressable due to wasted activities, due to having more lubricants spent in a given year versus what the actual equipment needs. And you can do that pretty easily. It's called a lubricant consumption ratio. I wrote an article about this about 3 or 4 years ago. You can read about online. It's lubricant consumption ratio. And also calculating waste, recognizing different activities and looking at the hours spent doing that, because it's all in the schedules apparently. So you can add up the different things that are being done. And then, look at the cost going into oil analysis, and then do a net present value 5 years out to showcase through the investment of certain changes. But you have to take action. These things don't happen in the first year. And let me take, for example, a case study here. I think I have right here. Here's a case study where Komatsu Works, they recognize that they had an intervention here because the failures per month were near 400. And what they changed was the contamination control. That's going to be better breathers, better filtration, better lubricant selection, better ways to apply it, and controlling or monitoring the conditions, mostly with particle counts in this case. But you see that this took several years, many years. Komatsu Works, it took, even in the first year, second year, the program was being implemented. It took time. And you can track these changes by looking at the simple stuff, the bearing replacement rate, the mean time between failure, the averages there on certain key components. But there's more than just simply monitoring the conditions of oil analysis and seeing that number change. There's an overall strategy here, even with like how often you're changing out the oils. Why are you changing the oils from a preventative maintenance schedule? What was the reasoning behind that? The oil can last longer. And so there's a lot of other cost factors there. I'm trying to answer your question holistically here, but there is, case study after case study showing how these metrics, they show on the results of why their case study was reporting the successes of a lubrication initiative. And it's documented. So I would encourage you to look at that. In this case here, this case study saw a 65% bearing failure reduction over a 6-year period. That's hard cost. that they saved, and that's almost all related to contamination control. And here's another one here. It says Cargill salt. The action taken was focusing, in this case, on lubricant storage and handling. Adding certain devices to focus on reducing the contamination levels down to a 16, 13, 12. There's a lot of debris in this Cargill salt facility. The low-hanging fruit they recognized is that they were able to reduce the oil consumption by 42%. So this is the hard dollars that were saved. 11,000 gallons in the first year alone. You can put that into dollars and recognize the savings there. That was the quick low-hanging fruit that was quickly and over several times paying everything of their investment. But the ongoing success was really the increased mean time between failure, the increased uptime. And even what oftentimes it's overlooked, but is the most important, is improving the culture, improving the job satisfaction. And that goes back to that work-life balance conversation. If we have surprise failures happening in the middle of the night and you have to work overtime, I have story after story of people having to experience that. And some people like the overtime, sure, but the new generation that doesn't necessarily like it. The next generation, wants to be able to have a good work-life balance. But not only does that help them and their ability to control their schedules, it also impacts the facility, being able to have more prediction on when things are going to need to be changed and proactively improving the equipment. Let me read through your question a little bit more. What sort of indicators should be included in the oil analysis report? Well, oil analysis is going to report conditions of the lubricant, like the fluid properties. So we need to know when viscosity is changing and accurately understand what the current viscosity should be. The other component is the contaminants. So you need to track particles, the amount of debris, those three numbers, like a 16, 13, 12 that I was showing here earlier. That's called an ISO 4406 contamination code that needs to be tracked. And then we're also on a predictive maintenance side, looking at the wear debris, the wear being produced as a result of the possible failure in progress. And then you also say, can you share some lubrication best practices that can help with extending the life of the equipment? Absolutely. I'm already doing this with better identification of how to inspect a machine. Right now, there is an enormous amount of waste happening simply by everybody doing lubrication inspection rounds, but not having any idea what to look for. It's just based on their intuition. That alone, recognizing things that are important and from a proactive standpoint, is huge. So thank you so much for that question, and feel free to, for others want to ask some more questions, I'll look at it in a second. Let me get back to where I was. So I was speaking on applying tribology. This is a key to enhance reliability. That's Noria's mantra, is recognizing the impact lubrication excellence has on achieving plant reliability or in creating a reliable plant. So why focus on inspection? Well, two reasons. This comes back to the next generation concept. One, it's easy. The ease of use, being able to implement better lubrication practice or inspection practices. There's no real new technology. It's a methodology. It's a thing that can be taught. And it's driven by those who are at the machine every single day. And in the process, it helps them learn about the machine so they can better relate to the operations. They can better, let's say it's a reliability engineer who hasn't been in the maintenance world very long. He can learn about the machine by going through better understanding how to inspect a machine. And it's an emphasis on examination and doing it more often. The other thing is the early detection, effective detection. You can cash in on the economics of finding things quickly, just like sensors. You put sensors on a machine for vibration and temperature. It's a trigger, real-time trigger. But that only goes so far and is important too. Layering on top of that is the everyday inspections, or however the frequency might be, by who can be nearby. It could be operator driven on those inspections. And deploying the root cause hound, focusing on how the root what the root is of the problem is, the repetitive why. An examination scale of the pin drop, looking for the smallest subtle changes. There's so much happening in machines that I see picture after picture, even the picture on the right here, that everybody sees as normal. And it's okay. Well, maybe it's not okay. They know it's not okay, but they're approaching it like it's not critical. So optimizing reliability is all about controlling the failure causes and recognizing what those failure causes are. Could be how we're changing or just selecting things about the lubricant. Yes, that might lead to a lubricant failure, then a machine failure, and then an overall consequence of failure. This is a different topic here, but this is the consequence of failure. But even just the cost of the lubricant, the cost of replacing the oil, the downtime associated to an oil change, the labor to that oil change, all of that can be a huge cost as well. It's amazing if you actually add up everything that was part of an oil change. It's 10 times, 15 times that than the actual oil and labor of that person itself. So every time you shut down a machine to change out the oil, it's several times more than that. And so we have to think about how can we monitor failures every single day. Reliability. What does a reliability engineer do? Ian, I listened to an article from a guy in the UK a few months ago that had a great story about this. A story about him as a reliability engineer, and he was asked while he was undergoing a surgery, and he was getting they're putting him under, and so he was having crazy talk, and the nurse was talking to him as he was going through, having crazy things being said. And one of the questions the nurse asked is like, "What do you do?" "Oh, I'm a reliability engineer." "Well, what does that really mean?" Well, the guy couldn't even answer it. He couldn't spit that out. What is a reliability engineer supposed to do? Well, the quick answer might be, I'm trying to catch failures or know why machines fail and improve uptime on equipment. And that's all true. But in addition to that, it's also about understanding how to avoid the failure from happening again in the future. Not just knowing the failures, the progress of the failure currently. And so that's actually proactive maintenance. Reliability engineering is all about proactive maintenance, seeing the root cause of the failure and recognizing how you can prevent them from happening in the future. So you have to have several ways to detect problems all along the process. Root cause first, every day, daily inspections. You're going to catch some of those. The cost of the organization is much less at that point. Then you can detect things through other screening, whether it's other condition monitoring or ferrous density. Maybe then a little bit later, as the failure is in progress, with elemental analysis. Then maybe vibration will catch it when the metal-to-metal contact is more significant. Once in a while, events will get through. But catching it over here is the lowest cost of the organization. This is the opportunity for the next generation to capitalize on the economics behind it. So proactive inspections, proactive maintenance, builds towards a reliability culture. Increase equipment availability. That's important. Increased equipment availability. That's the idea of increased uptime. It's about having a reliability-centered maintenance program, understanding what that means, and being condition-based on their maintenance, taking actions on changes and maintenance work on a machine based on the conditions, not necessarily just based on a historical data point. Being early root cause detection oriented. A reliability culture is when the organization focuses holistically on preventing failure at every level of the organization. So we have to train people to look for things and be understanding the why behind better lubrication practices, even though they might be not living it every day. It could be you're asking, what are the things to look for that could help, look at the economics behind an investment and the return on investments. Here's a recent case study. LPD stands for Lubrication Program Development. Wood Grain is was a customer in the United States here, and they were earlier on. For every hour of downtime, the plant was losing nearly $10,000 every minute. Every hour. Before you can see the downtime minutes per component that they were experiencing on different components, and the years went on between 21, 22, and 23, before and after. What they changed, they focus on the things they could control on a lubrication and a contamination control side. Particle counts, lowering those contamination codes, focusing on lubricant storage and handling, better filtration, penny loop on filtration. They started using lubrication programs, LubPM, as a program to do their routes and do their inspection rounds. Even from the visual side of things, this is the before state, where things were just haphazard, organized and disorganized. Even when it looked okay to some, like this looks okay to many people. But if you look at the details and how the lubricants are being handled, it's actually showing a lot of ingression of contaminants. And we don't want to use funnels, for example. Where they are today, they have a dedicated lube storage facility. That's what's inside. Filtration for every lubricant, large filtration units here, better understanding what the oil levels should be. They're using better tools. This is how you engage the next generation through applied tribology. These filtration solutions, these breathers, the software to monitor the lubricants in use and making sure it's being applied the right way. This is a particle counting device to monitor the contamination levels every day, even just ensuring that we have the right lubricant going into the right machine. I already showed a couple, I showed this case study already in this one, but there's more. There's lots of examples of every one of these case studies, by the way, are found online. You can read the details, their charts, their data that they show, that you can also follow their same steps on how they reach success. Blue scope steel, 67% reduction in failures were avoidable. They recognize that gearboxes don't have to have like a lifespan of 3 years or something. They can last 10 years. They can last 20 years. But there's often a mentality, oh, we've always had to replace those every 2 or 3 years. That's just, that doesn't have to be that. We can make a difference there. I think that's where the next generation can have an opportunity in their role. Visi, recognize that there's a lot of importance on training people on what to do and better filtration. 90% reduction of moisture contamination reduced 64%. That alone, 64% of their downtime in the first 2.5 years. And so on and so on. Even more recently, I was going back to a facility that this Nissan Automotive, they had a case, they won a battle award about 10 years ago. Battle award is an award to the best lubrication program around the world. And I was wondering, how they're doing. At the time, they achieved results 10 years ago of a 53% reduction in breakdown frequency, 54 in downtime, all related to these things right here. This is Nissan, major facility recognizing the role of applied tribology. So 10 years ago, they won the battle award. I went back there in April of this year to see what they were doing, and I was blown away, not necessarily based on the things on the machines that they were doing or even how they were applying their procedures, but the culture that had developed since then. They have a better work-life balance. Everyone knew their role. Everyone was having good job satisfaction, recognizing that their tactics with applied tribology were actually addressing the things related to the skills they learned, and they were making a difference. So back to what Wes was sharing at Reliable Plant, the slides I showed at the beginning, this is seeing it in action. And there's plenty of articles and videos that showcase this. And there's lots of different kinds of low-hanging fruit that anybody can help to recognize a quick return and shorter payback period on lubrication initiatives, whether it just to get the cost savings, that return on investment. It could be lubricant consumption optimization, like I mentioned earlier. It could be eliminating those waste activities. And then, of course, like my focus that has been here is about catching faults proactively before they begin. But this all begins with knowledge. Every bit of this begins with teaching people the why behind machines that fail. Everyday machines fail, and they think it's just the end of the machine's life, and they have to replace it. And downtime is inevitable. Well, maybe eventually, but it can be significantly reduced. So through training, this can drive that culture to sustain these initiatives that otherwise can be just seen as flavors of the month. At this point, I would like to share a few things about Noria. Before I do, Ian, maybe it's a good time to go through some Q&A. Does anybody have any questions at this time?
Absolutely, folks. Yeah, any questions at all, please give us a shout. Now's your chance.
Well, I'll give you some time to think about it if you have questions. As you're thinking about it, maybe I'll share a few things about Noria that you may not be aware of, and then I'll come back and ask you one more time. If you're thinking about a question, you can write it in the chat. I see the chat behind the camera here, so I can look right at it if it comes up.
Can I ask a quick question?
Yeah, go for it, Lisa.
You quoted earlier or mentioned that lubrication is the #1 cause of machine wear and failure. How would you kind of, obviously there's not sort of official research. Is this a Noria, like, is it, if we were to quote that,
This is not
coming from you, or is it, how have you uncovered that?
This is from dozens and dozens of sources. I showed a few of them. I showed SKF and SK. That's their data of contamination and lubrication issues being #1, #2. You can ask Fault Gearbox. You can ask Sue Eurodrive. You can ask all of them, and they have data on why their machines from their users over the years. And we have data going back. This is not just a Noria thing. This is OEMs and user groups throughout the world. I have a case study from the Canada Research Council, and they're showing that the 82% of the wear that's occurring on their industry equipment is because of particles in the oil. That's the National Research Council of Canada. And so it's all out there. It's just rarely does someone distill it down into a simple statement like we're doing. The only thing we're doing differently in Noria is just distilling it into like, hey, come on, guys, we have to do something about this. This is where the opportunity is. Doesn't mean it's easy, but the alternative is also not easy,
Thank you. That's great.
Good question. Sam, I see you have a question. Well, I got a few here. We go up to Penda. What do you think about ultrasonic devices to monitor lubrication? I like ultrasonics. In fact, I think a few things about it. One is that it's the best way to probably re-grease a bearing. For most bearing applications, not all, is to use ultrasonic technology in the process to optimize the volume, to optimize the interval. It's not the only way to go about it, but it definitely can optimize it rather than just follow a default volume. I like ultrasonics, and it does also jump into that proactive domain in addition to the predictive domain. Sam, you had a question. Where is the best place to start on a path towards lubrication excellence? Inspection, storage, analysis. Well, I think it's really just every facility, and I've been to, like I said, a lot of facilities over the years, and every facility is a little bit different. Yes, there's some commonalities, but you need to get a really good benchmark on ranking the things that are the biggest challenge areas at your facility, and then build a plan from there. It might be inspections, but more often than not, it's probably just simply going through some training, letting the teams at different scales of training. So there needs to be an individual that's kind of tasked as hey, you're going to be the champion for lubrication. And then there's going to be other types of training. It could be just an hour training for the masses, but then maybe 3 to 4 hour training for a smaller group. We have to educate people in the why. And then that's when you can then focus on the little breakout focuses, like I call them group inspections, where you teach people in different departments together and let them share knowledge across departments on how to inspect a machine. And if you have certain things depend on also how much money do you have to invest. The more money you have to invest, the quicker you can get to that return. But if you don't, you need to take things slower, then you can invest in the lower cost opportunities, like better labeling of machines. Back to inspections, that's another one. And a few others. Martins, you ask, does an organization need to have all of the predictive maintenance technologies on site, or limit it to the ones that are most valuable to address failures like vibration analysis and oil analysis? No, they don't need to have all of them, but every one of them will, any well implemented condition monitoring solution will provide a return on investment. Okay, so they all will provide a return on investment. I think the real value comes to when you have someone who is bringing it together. What you don't want is to have a vibration team, and then they trigger corrective actions or faults they find based on their data and data alone. And then you have an oil analysis team, and then you have whoever has been told to do inspections, and then you have these ultrasonic folks, and you have somewhere in-house, somewhere contract. If they're all separate, then you're not really getting the value. Condition monitoring is about unifying those technologies and seeing the health of the machine, the health of through the oil, through other conditions, but seeing what the current health is of the machine. And so that's where you get the most value to address the failures. And Martins, you said to address failures. I like to suggest that instead you focus on finding value to address the root cause. Find the things that lead to failure. Because we predict failures all the time with vibration analysis. That helps minimize the downtime. But the real opportunity is eliminating the number of events of failure by solving for the root causes that are already well established and well known. So a good question though, Martins. Thank you for that.
Can I ask one more question?
Yeah.
Just being involved in this mainstream community and being very involved in actually bringing, delivering your courses. You're best in the world, and we're very proud to be part of this. And obviously we provide the public, and we can take it privately. Obviously, what we've noticed in Australia versus, where you are, your volume of people is so large. Many organizations have dedicated lubrication teams and, some tribologists, and they're going through certification and they work up, whereas Australia is a smaller volume of people, smaller teams. And many don't have, dedicated best practice teams. And there are a lot of technicians who come in and they've got, spillage and the wrong contamination and the wrong oil and etc. But it just seems like, I don't know how we lift more commitment around the importance of this. And who would you say, I had a call yesterday with a client going, we should be bringing in a real dedicated lubrication person. Who would you say, would you start with, really champions this, like a maintenance, knowing the structure here is maintenance manager, maintenance superintendent, asset management, those kind of, there are not many actual fully qualified, very qualified lubrication who go, and when would you do the certification?
Yeah, that's a great question. And I recognize there are differences in the regions around the world. I've trained and built lubrication programs in every continent. Well, not every continent, but most continents, and including several in Australia. And there are differences. And there always is the question, is this something that needs to come from the top down, from management, or is it something that you build from the bottom up? I think that it's always going to go back and forth, but until you recognize it's both. The ones on the plant floor need to be the ones that see the why, but if they don't get support from management, so when I was asked earlier, where to start, I said start with training, and I'm not trying to throw a whole bunch of several day training at everybody, but everybody needs to know the why. And so if you have people on the plant floor really recognizing what I'm saying, they know it already, that contaminants are causing failure, but the middle managers, the upper managers, They just want results today. And they're not really seeing what's causing their machines to fail. The charts that I show, and they don't believe it on their equipment, it's because it's not intuitive to them. It's not intuitive that contaminants that they don't see it in front of their eyes, they don't feel like it's real. And so they have to go through that training as well so they can recognize that even the debris inside of their clean conference room, debris inside that room is more than enough to cause damage to their equipment. And so it's what we can't see, even the smaller stuff that causes the more damage than what we think is really the most important thing. And so it does come down to training first. You do have to identify a champion. If I was to identify one thing that really is like, it's going to make or break a successful lubrication program, it's having a champion. Now, that might already be identified because someone's already naturally motivated, but if there's not, then it actually comes back to training again. Because what I've also seen is if you train a group of 15 people, let's say, before that, there is no dedicated champion. You're going to find out during that several days of training who really starts to naturally participate more, who starts to be seen as the influencer to those around them. Like they naturally have a skill set. That person talks, everyone's listening. If those skill sets start to be apparent, this is a culture thing. Then you can then identify, okay, we're going to work with that skill set and that natural passion to train that person and make them the champion. But then at that point, it's not just about training that team, it's about working your way up so everyone sees the why.
That's great. I mean, I just think it needs to be, it really needs to be revered more. I think sometimes it's just, there's just no dedication to it. So then there's no training to it either. So you got to start with the champion to then bring seriousness into the organization and get better behaviors than this repeated poor behavior of just coming in and not having the why. So thank you for sharing that. I mean, we need to do more, just bring more seriousness or more value, or the value proposition, why organizations should do more of it over here. Yeah. Thank you.
Well, if it's the #1 cause of failure, they need to learn the why, and they need to be recognizing it's not just a finance game. It's also got to get a little bit dirty with it too, and see how the machines are seeing the wear occur. That's not easy for everybody. That takes a mechanical mindset.
Yeah.
So I appreciate that question, Lisa. Thank you.
It would be awesome to know on this call with the cross section of organizations who you can pop in the chat who does have a dedicated champion on this in their organization. Wouldn't that be good to know? So
I don't know anybody on this Zoom call here, but I mean, I've got a list upstairs of dozens of lubrication champions that I use them as referrals at times, or references, not referrals. References when someone wants to hear a success story, and the passion, you hear it in the person. You don't even hear what they're saying. You're seeing that how they're saying it. How they convey their message is really what matters.
very good.
I can keep talking, but again, I know I'm losing time here.
Another question, hey, Ian.
Absolutely, yeah, for sure. I think folks, we have run out of time. We are literally 2 minutes over. If you have any questions at all, now is the time to shout. But if you wanted to reach out to Bennett, then please reach out to us. We can surely be able to introduce you to Bennett and Noria. Go on, Bennett.
Ian, do you mind me if I share one more quick thing? If anybody wants to look at this Ascend chart, just message me, email me, and I'll send you a copy. It's a great way to visualize all the components necessary in building a lubrication program. I didn't get a chance to get into it, but I'd be happy to share that to anyone that reaches out to me.
And your email address, Bennett, is?
So bfitch, so my name, Bennett Fitch, bfitch@noria.com.
Fantastic. Okay, brilliant.
I could put that in the chat.
Put that in the chat while we're doing that. Fantastic, Bennett. Thank you for all of your expertise this last 90 minutes. It's been great. Thank you, folks, for joining us this morning in Australia. And I think, Martins, you're in Nigeria. So thank you for joining us as well. And yeah, please join the community group. If you haven't already, there are heaps of content. Bennett's session will be recorded and will be on there for all of your colleagues if you want to pass it on to them. And there are opportunities to meet with thousands of other maintenance and reliability experts. So, Bennett, thank you so much. It's the best, or it was definitely the best studio we've seen. I love it. I really like that. I'm very jealous. And thank you so much for joining us. And thank you everyone for joining us for the masterclass, and have a wonderful weekend.
Thank
you all.
Thank you, everyone.
Have a good
Cheers,
weekend.
folks.
Bye, everyone.
Not only
folks.
great background, but you're an incredible educator. So thank you.
I appreciate that.